adhered to the surface of the sodium chloride. It is not a part of the sodium chloride crystal. So this is how we did this. So key innovation in this is suitable for production in solar pans. Works on variety of natural brines. We took seawater, we took subsoil brine water, and from each case we could generate this kind of modified sodium chloride crystal, and recycling of glycine was possible. And is it really spherical? If you look at the original crystal of sodium chloride, see that this is mounted on a glass fiber for a X-ray diffraction experiment. It looks like a sphere. This is sodium chloride. And you can see these rhombic phases here, right? So this is basically what we did. I have already explained, so I will not spend time on this. Now this free flow, is it really flowing better? So we did this experiment. This is called angle of repose. What you do actually is a crude experiment, but you can tell. You have to take a funnel and put sodium chloride or your crystal, whatever you want to do, put a known amount of it on it, and then you release the funnel from below and allow it to come out. When it comes out, it creates a kind of a heap, and then you measure this angle. So if the angle is less, that means it is more flowing. So we have compared this with cubic crystal and the rhombic dodecahedron crystal, and we saw that our crystals are better flowing than the cubic crystal by this quantitative measurement. We published this paper in Crystal Growth and Design. We also filed a patent which was granted, US patent. Later on we filed a PCT patent, and there are many countries, this patent is there. Finally, media came up. They started praising our work, saying many good things. It came in Chemical Education Today. It came in Reader's Digest, where they said that 33 new ideas from all over, and out of these 33 ideas, this idea was also included. It came in Chemical and Engineering News, New Scientist, New York Times. Not only that, New York Times came out at the end of that year, the 6th annual year in ideas. They said salt that does not stick, and that was also included in that. There are many comments in the internet. I will not read this, but I will read only one to ridicule myself. One guy says, easier to pour. Yes, that's a pretty big problem, especially now when quartz ground salt, flavored salt, sea salt, even volcanic asphalt are more readily available, waiting to be picked up in your fingertips and flung onto your food as a sensory pleasure. Let's take that away and replace it with easy pouring salt sprinkles. Seriously, can't we assign these guys something more important to do? So this is the comment somebody wrote, and with a pleasure I accept that, because this is what it is at the end of the day. This particular project gave me a lot of pain, a lot of pleasure, a lot of fame, and this kind of criticism as well. So as a scientist, we should be able to accept everything, and I accept it. Actually, if I look at it, we have a patent, yes, US patent, PCT patent. Is it commercially viable? No, by no means. If you have to make it commercially viable, you have to do further research. Chemical engineering research has to be done, because whatever we have done, it is in 500 ml beaker, means half a liter. And if any one of you has seen what a salt farm is, you will realize that this is nothing. I mean, you have to solve a bigger problem, which we have not ventured because Hindustan Liver finally, for some reason, were not interested. Neither was I, just tell you the truth. So, this is what it is. Finally, I must thank these two students. My first student, Dr. Amol Vallabh, he is a reader now in Baroda, and Dr. Darshak Trivedi, he is an assistant professor in NIT Mangalore, and Hindustan Liver Limited Mumbai, for kind of forcing me into this exciting project, and CSMCRI, who gave me my job, first job, to launch my independent career as a scientist. And finally, I thank you very much for your kind attention. Yeah, huh? Edible, yes, of course. It is edible because glycine is used in dietary supplement for some kind of taste, pleasure, or some kind of thing. That we have checked. It is edible. And glycine is amino acid after all.
Any more questions? Okay. Thank you, sir, for your lucid talk. The next part of the program is we'll have a short tea break. Here are a few announcements. For people who are submitting photographs in the photography and art exhibition, which is at the Centenary Building, 2:30 p.m. Hello dear friends, we now have an exciting demonstration by Dr. Shomi Gohopolli from Lady Brabant College. Ma'am did her BSc and MSc from Calcutta University in biochemistry. She did her PhD from IACS Kolkata under the guidance of Dr. Siddhartha Roy. And she did her postdoctoral studies from University of California, San Diego under the guidance of Professor Subramani. So I would like to invite ma'am to come up. We would like to felicitate her. I request Devdatta to please. To please felicitate her with a bouquet. So we expect this to be an interactive session. So students, please participate. It's for go.
Good afternoon, students. So from the morning you have been listening to quite a lot of lectures. So the first experiment, I need 3 volunteers for the first experiment. So the first experiment is yeast air balloon, and we will actually learn about the chemistry that is going on in the living systems. Oh, another one? No one? Come on, it's a very simple experiment. You need just 2 things and tie up a balloon. Okay, so what we will use for this yeast air balloon experiment is just a simple sugar that you use in day-to-day life, and here is yeast, which is an active waste, and it's a dried form. That means it has a coating. So when you add it in water, the coating will be dissolved and it will be active. Now, any idea what an yeast is? I think you have learned, right?
Organism.
An organism. Basically, it's a unicellular fungus, and it's an eukaryote. Okay? So we will just mix these 2 things. So we will do in a big scale and in small scale. So just come forward. So add this sugar. You have this spoon here. Okay, first of all, you do one thing. For these 2, we need bigger balloons. So just inflate these balloons, keep them. Just inflate once, and then release the air, and just keep them aside. And for the little one, we need a smaller balloon. Release it. No, a little. A little bit. Otherwise, fine. Okay, we can use the big ones also. Use the big ones. Use this one. Take this one. Give that to me. Take this one. Okay, now mix one in a bottle, one in a conical. So mix 2 spoons of sugar in each. You add 1 spoon of sugar. One each. So the rest, they are just adding the sugar and the yeast. So dissolve. Just add a little bit of water. And dissolve this. Just add a little bit of water. Mix it so that they become solid. You just put the cap. No, a little bit. And just dissolve it, shake it. You also add some water in both. Just this much will be fine. Now we will add the yeast. Yeah. Let's shake it. Now just add 4 spoons of, where is the spoon? In this. So just add 4 spoons of, or a little bit more, you can add 6 spoons of yeast into each one of these. So any idea where this yeast is used? Actually, I procured this yeast from the grocery. Bread. Cakes. Any other? Cookies. In wine, beer, and alcohol, right? Yeah, shake it. Just one full, 1 spoon. Okay, now tie the balloon. You just tie it like that. 1 each. And why they are used in these food materials? Why? What makes it fluffy? Any idea? Carbon dioxide, right? So what we are adding here? Sugar. So in making breads and in making cakes, we add sugar, right? And what is sugar? It's a carbohydrate. and in making the cakes also we add flour and sugar. So that are also carbohydrate. In bread you may or may not add sugar, but you add flour, which is a form of carbohydrate. And flour is a more complex form of carbohydrate than sugar, right? So here we are just adding the sugar. So that is the food for yeast. And what the yeast will do is it will ferment, right? So now just type the balloon. You have added? Okay. So tie up. Which ones are the inflated ones? This one. Another one. Another one. Okay, if you can't, then I can help you. Okay, so let us give some time to this. In the meanwhile, we will do another experiment. So for that, I need another set of volunteers. Thank you. So the next experiment will be an experiment which is usually done in dairy farms to check the quality of raw milk that is being brought in by the farmers, which is known as a methylene blue reduction test. So I need at least 2 volunteers. They are from the back. You just need to add 2 things. Okay, so these are certain milk samples and these are raw milk. Raw milk means they are, so the milk that we use, those, if you have carefully looked, those are all pasteurized milk, right? So these are raw milk. So just add marked tubes and add these samples. I will explain the reaction a little later. Just add these samples, say like this, okay? 1 in each. First mark the tubes. You add 2, you add 2. And here we have one reagent which is a methylene blue, which is a dye. So these are different milk samples and we will test the quality of these raw milk samples. This is B. Now add this reagent, 2 drops in each of the tubes. And we will keep this milk as a control where we haven't added any. We have added, mixed it. Yeah. Please add a little bit more in this tube. Which sample is this? B. So this is the control milk one. Okay, mix the dye properly so that it takes a uniform color. you go back to your seats. Now both of these reaction need some time. So in the meanwhile, we will have a look at the basis of these experiments that we have performed. So basically all these experiments, the common thing to all this is the chemistry that is going on in the living system. So the chemistry of the living system, the discipline is known as biochemistry. Now biochemistry is basically the study of structure, the composition and all the chemical reactions that are going on in the living system to sustain the living system, right? And these are actually the macromolecules. Now macromolecules, I think you have an idea that macromolecules are actually polymers of some repeating units, and these macromolecules are the protein, carbohydrate, nucleic acids and lipids, right? And this biochemistry actually tries to explain life in terms of biochemical reactions. So all the experiments that we are